Hi everybody. Today we're going to learn about triangle congruence with me, David Walker Peacock. All right. So our first triangle congruence theorem that we're going to learn about is this one right here, known as side, 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 or triple S. So with side, 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 let's talk about what this means. Basically, if I have two triangles, and I know that their corresponding sides are congruent, then if all three sides are congruent and they are two triangles, then they are congruent triangles. Yay, that's our first one. That's side, side, side. But we don't only learn about side, side, side. We also learn about side, angle, side. So with side, angle, side, the idea is if I had two triangles, and they were formed by the same angle and the same two sides, there's only one line I can draw that goes from this end point to this one. And if these are congruent, it's going to be the same line and same distance that I would draw for those. So, side, 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 angle, side proves triangles are congruent. Now let's talk about angle, side, angle. So with angle, side, angle, where side, angle, side had an included angle, by the way, let's talk about included real quick. If you look, this angle is being formed by the two sides. So if I was to just go naturally, I would go side, angle, side. Now, with this one, it's angle, side, angle. So, if I know that one triangle looks like this, and then I have another triangle, and I know it starts with this, the thing is, if I actually extend these lines out, what you're going to find is they end up creating the same triangles that we had over here. So angle, side, angle is all that we need to prove triangle congruence. Now notice right here we have once again an included side. So when it goes angle, side, angle, the line is in between the two angles. You would naturally just go, there's the angle, there's the side, there's the angle. But now let's talk about what happens when it's not included. And then we're going to do that by talking about angle, angle, side. So with angle, angle, side, the idea is this. You know what? Before we actually do that, let me give you an example of why this works. So here we go. Here's an angle, and here's a side. Now, if I took another triangle, and I said, here's my angle, this would hopefully go straight up to here. But the thing is, if I moved it closer in, it's not going to still go straight up to the end point. It's going to go somewhere in the middle. And if I move it too far out, it's going to end up going out too far. So there's really only one spot where it ends up forming the perfect triangle. So all we actually need on angle, angle, side, angle, angle, side. Now that's angle, angle, side. Next what we're going to talk about is our final congruence theorem. And this one only works with 90-degree triangles. Only right triangles. And that is hypotenuse leg, or HL. So basically, if I have one right triangle, and then I have a second right triangle, if I know that the hypotenuse, which remember is the side opposite the 90-degree angle, is the same on both, and then one of our legs is the same, well, think about it this way. If I knew that this was 3 and this was 5, there's only one possible value this could be. I would do 5 squared minus 3 squared, so 25 minus 9, which is 16 square root. This would have to be 4. And if these were the same, these would also have to be 4 because of the Pythagorean theorem. So even though this is only going to be two sides in an angle in a way that we'll find out later doesn't work, because it's a right triangle, it's basically also like side, 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 or really any of these forms. All right, now for two that don't work. Here's our first one that doesn't work. It's triple angle or triple A. Angle, angle, angle. So let's talk about why, because you might go, but Mr. Peacock, side, side, side worked. And sure enough, if I draw this, you might think, well, wouldn't another one with the same angles be that same size? But that's not true. Because think about it this way. If I was to zoom in right now, and we were to look a little bit closer, is this triangle the same size it was before on your screen? Is it now? But the angles didn't change. I just moved it. So the fact is, in the end, angle, angle, angle only proves what we call similarity. They're the same shape, but they might not be the same size. Now we have our last one, our most important, not one that works that we could have. That's what we call angle, angle, side, or for short, SSA. Now, if we're talking about angle, angle, side, let's talk about why it doesn't work. Because the answer is not just, it forms a cuss word, so we can't, because as you just saw, it doesn't form one. That's not a good reason. Don't get me wrong, it's a reason. But the reason that it doesn't work isn't that. To show you the reason why, I'm going to take out another sheet of paper, and we'll come back to this. So what I'm going to do is I'm going to create an angle. Now I have this special set of lines. One is red and one is green. What I'm going to do first is I'm going to set up my red line right here. So this is my red line, it has that angle. And what I do is, oh look, there's the triangle. That's great. But here's the problem. There are two different triangles that use the same two sides and one angle. We don't know which one it is. And so because of that, it does not work. So when we look at side angle, side, side, they just don't work. And that's the idea. So that's triangle congruence. Apparently, I can't thumbs up very well from this, but that's triangle congruence. Thank you very much. Have a great day.